Assalamu alaikum warahmatullah. Our third lesson today is still going to be on alkenes chemical properties. Last time, the previous lesson, that was second lesson, we looked at some of the chemical properties of alkenes, which was hydrogenation, and we said that hydrogenation is the addition of hydrogen molecules across the double bond, and alkenes were converted to alkanes during the process of hydrogenation. And the condition that was necessary for the process of hydrogenation to take place was nickel catalyst and a temperature of around 180 to 250 degrees Celsius. That was the condition that was needed for the process of hydrogenation. Apart from the nickel catalyst, we also said that we can use palladium as a catalyst. And the industrial application of hydrogenation is applied in industries in converting oils to fats. And we say that oils are unsaturated while fats are saturated. Therefore, we carry out the process of hydrogenation in oils so that we can be able to convert them into fats. Because if you look at the cooking oils, we have those ones which are in solid state and those ones which are in liquid state. The ones which are in liquid state means that they are unsaturated, while those ones which are in solid state are saturated. And the second chemical property that we looked into was halogenation. That is addition of halogens. We can add halogens like chlorine molecule, we can add bromine molecule, we can add iodine molecule across the double bond. And what happened was the process of hydrogenation of alkenes, of halogenation with alkenes was taking place in absence of UV light, unlike alkanes, whereby for the reaction to occur between halogens and alkanes, sunlight was being needed, and light energy was used in breaking the molecules into atoms for that reaction to occur. And this reaction here does not need UV light and doesn't require sunlight. So that is the difference between the reaction of halogens with alkenes and alkanes. So alkenes does not require UV light, but even in the presence of the UV light or the sunlight, it will occur. But now it will occur on a faster rate than when there is no light energy. While alkanes, that reaction only occurs in the presence of sunlight or UV light. So that's the differences between reaction of halogens with alkenes and with alkanes. We also looked at addition of hydrogen halides. When we talk of hydrogen halides, here we are talking about hydrogen fluoride, hydrogen chloride, hydrogen bromide with alkenes. So we are adding hydrogen halides across the double bond, and this reaction, as we add the molecules of hydrogen halides, we are converting alkenes into alkanes by adding a molecule of an atom of a halogen. For example, if you add hydrogen chloride in ethene, we get chloroethane. If we add hydrogen bromide, we get bromoethane. If we add hydrogen iodide, we get iodoethane. So the reaction also depends on the strength of the bond which exists between a molecule of the hydrogen halides. For example, if you look at hydrogen fluoride, the bond in hydrogen fluoride is so much stronger than hydrogen bromide or even hydrogen iodide. So in that reaction, some heating and to break that bonds will be needed for that reaction to take place. Now, as we move with the third lesson, which is still going to be on continuation on chemical properties of alkenes. Now we check on self-addition reaction. Self-addition reaction. So that was now the fourth chemical property, self-addition reaction. Self-addition reaction. So talking about the self-addition reaction, an alkene molecule forms what we call a monomer. An alkene molecule forms a monomer. So when we take a monomer and join them together, we get a substance known as the polymer. Therefore, this reaction is referred to as polymerization, and the product formed is known as the polymer. So we say that a molecule of an alkene, an alkene forms a monomer. It forms a monomer. So monomers are joined together to form a polymer. So we have here monomer plus another monomer giving us a polymer. So this process is referred to as polymerization. The condition needed for the process of polymerization to take place is high pressure. We need high pressure for these ones here to be joined. So we have the condition needed is high pressure. We need a high pressure for a monomer and a monomer to be joined. For example, let's have a look at ethene and ethene. So if we have here ethene plus another ethene, we get polyethene. We get polyethene, which is the polymer. Therefore, if we look at the structure, that is a repeated unit of joining two monomers of ethene. Hydrogen, hydrogen, hydrogen. During joining up, we call this one as addition polymerization. We have addition reaction of polymerization. So where we have the double bond opens up, another molecule joins up. So we get this and another molecule joining up. Then this one opens here at the end, and this one also opens here. So we have this was hydrogen, 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 hydrogen. This here is N. So we have an ethene plus an ethene joined up to form polyethene. This is polyethene. And you can see that this one here, the bracket should touch this bond. So we should not enclose this bond. This shows that we can still add other molecules, meaning that it is still open to join more molecules. And N represents the number of monomers joined up to form that polymer. So we find that N represents number of monomers joined to form the polymer. Joined to form the polymer. The number of monomers joined to form the polymer. So we get that N is equals to molecular mass of the polymer, molecular mass of the polymer divided by the molecular mass molecular mass of the monomer. So if you have, having been given the molecular mass of the polymer, and you have already identified the monomer, therefore we get the value of N as molecular mass of the polymer divided by the molecular mass of the monomer. So that's going to give us the number of monomers joined up to form the polymer. Let's also have a look at propene plus propene. If we have here propene, we have propene plus propene, giving us polypropene. We get there polypropene. So propene, we have C, put the double bond there. So we have hydrogen, hydrogen, hydrogen. This one has one hydrogen, and hydrogen, hydrogen. Maybe plus another one, C, hydrogen, 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 hydrogen. So we get this one here, giving us, now we need to join. This is a monomer and a monomer, propene plus a propene. When forming the polymer, the point of joining, where the joining is going to take place, occurs where we have the double bond, since it is unsaturated. So the joining cannot occur at this point here. It is only going to occur between this carbon and this carbon. Therefore, we need to make this one in a bending position in such a manner. So we have it that way. This one here is hydrogen. We have hydrogen, hydrogen plus C, double bond C, that is hydrogen, CH3, hydrogen, hydrogen. Therefore, now we are going to get C, opening up on that side, this one also on that side, having up here CH3, hydrogen, 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 hydrogen. So you can see that we have polypropene, that is propene plus another propene, giving us polypropene. The general representation, we can have it as C, double bond. We have here CH3, that is hydrogen, hydrogen, and a hydrogen. We put here N. N here we have said represents the number of monomers being joined up. Then the general equation gives us that we have CH3, then joining up that we have hydrogen, hydrogen, hydrogen. Then we enclose, we put our N there. So this is polypropene. That is the polymer being formed in that reaction. So we call that one as self-addition reaction in formation of polymers. The process is referred to as polymerization. The condition we have said is high pressure needed for that reaction to take place. Then the fifth chemical property is reaction with concentrated sulfuric 6 acid, or hydrolysis with concentrated sulfuric 6 acid. So we have reaction with concentrated sulfuric 6 acid. Alkenes are hydrolyzed with concentrated sulfuric 6 acid to form alkyl hydrogen sulfate. When we hydrolyze alkyl hydrogen sulfate, that is addition of water molecules, we are going to get alkanols plus dilute sulfuric 6 acid. Then the two are going to be separated by fractional distillation, whereby, for example, if it is ethanol distills out at a temperature of around 78 degrees Celsius. So if we have here ethene, we have ethene, which is C double bond, that is hydrogen, 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 hydrogen. We are reacting it with concentrated sulfuric 6 acid. We get ethyl hydrogen sulfate, which is going to be COSO3H. This one here, hydrogen, hydrogen, that is hydrogen, hydrogen, hydrogen. So we name this one as ethyl hydrogen sulfate. This is ethyl hydrogen sulfate. Ethyl hydrogen sulfate. If we use propene, we get propyl hydrogen sulfate when we react it with concentrated sulfuric 6 acid. Now we want to carry out hydrolysis. We add water to the product, which is ethyl hydrogen sulfate. So we have here C, we have that one there, SO3H, hydrogen, 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 plus H2O liquid. So the product is going to be C, hydrogen, 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 hydrogen. This one is OH, the liquid, plus H2SO4 aqueous. So now this is now ethanol plus dilute sulfuric 6 acid, meaning that alkyl hydrogen sulfate is hydrolyzed to an alkanol plus dilute sulfuric 6 acid. The mixture is being separated by fractional distillation. For example, in this reaction, ethanol distills out at a temperature of around 78 degrees Celsius. It will distill out. So the reaction here is referred to as hydrolysis. The reaction is referred to as hydrolysis. Then the next part, that's the sixth chemical property of alkenes, is reaction with oxidizing agents. Reaction with oxidizing agents. So the acidified oxidizing agents that we are having when carrying out oxidation, we have acidified potassium manganate 7. We also have acidified potassium chromate 6 ions, whereby alkenes are oxidized to alkanols. Alkenes are going to be oxidized to alkanols, and the oxidizing agents get reduced. And during the reaction, there is some color changes to the oxidizing agents, showing that they have been reduced. So the next one, that is the sixth chemical property, is reaction with oxidizing agents. Reaction using oxidizing agents. And the oxidizing agents we are having here is acidified potassium chromate 6, acidified potassium chromate 7 ions, which is KMNO4. It is acidified, or we use acidified potassium dichromate 6 ions, which is K2Cr2O7. Those are the oxidizing agents that we are going to use. So the reaction is referred to as oxidation reactions, and alkenes are going to be oxidized to alkanols. For example, if we have ethene, that is ethene, hydrogen, hydrogen, hydrogen. We are adding an oxidizing agent, which is KMnO4, acidified, or we can also use K2Cr2O7. So we can either use this or use this one here as an oxidizing agent. So we get here hydrogen, hydrogen, that is hydrogen, hydrogen, we get OH, and here also OH. So since we have the OH, this is an alkanol, but we have two hydroxide ions. We have to identify the position of the hydroxide ions, and we use diol. Therefore, it is named as ethan 1,2-diol. We call it ethan 1,2-diol. Ethan 1,2-diol. So this is an ethanol. And the color of the oxidizing agent to indicate that they have been reduced, acidified potassium manganate 7 ions changes from purple to colorless. Purple to colorless. This is due to reduction of manganate 7 ions to manganese 2 ions. Manganate 7 ions to manganese 2 ions. While acidified potassium dichromate 6 ions will change from orange to green. This is due to reduction of chromate 6 ions to chromium 3 ions. Chromium 3 ions are green in color, and they are the ones which are responsible for the green color after the reaction. So the reaction is referred to as oxidation reaction. We call it oxidation reaction, and that one there. Then now we move to the last part of alkenes. The last part of alkenes is going to be on their uses of alkenes. No, before we check on the uses of alkenes, we check on reaction with bromine water. Reaction with bromine water, which is the 7th one. So we have reaction with bromine water. So working with this one here, bromine water also oxidizes alkanols to alkenes to alkanols. The color of bromine water is orange in color, and it turns colorless, so it gets decolorized. And bromine water is used for test of unsaturation, that is the presence of the double bond or triple bond in hydrocarbons. So we say that if we have here that is hydrogen, 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 hydrogen. This one here is ethene. We are reacting it with HOBr, which is orange. Bromine water is orange in color. Therefore, we are going to get C. This one here is hydrogen, 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 OH, and Br. This is an alkanol due to the presence of the OH ions. But since we have the bromide in the structure, we need to identify the bromine. Therefore, we call this one as bromoethanol. Bromoethanol. We name it as bromoethanol, and the orange color turns colorless, so it gets decolorized. That indicates that the substance here, that is an alkene, is unsaturated, because bromine water is used for test of unsaturation, Then now we move to the last part of alkenes, which is the uses of alkenes. We check on uses of alkenes. Uses of alkenes. Uses of alkenes. One use of alkenes used in making of polymers. We have synthetic polymers. We have polythene bags. We also have plastic containers. We also have even the shoes made of plastics. So those ones, like if you check that seat, the plastic chair, at the back you will get PPP, polypropylene. So, which means one use of this is used in making of polymers. Used in making of polymers. Into bracket plastics. We have plastics. We have the second use. We have ethene. Ethene is used in ripening of fruits. Like we have the mangoes, bananas, we have maybe tomatoes. Once they have been harvested, so for them to ripe very fast, we put them in an enclosed place, then pump some of ethene gas, so that to fast and also speed up the rate of ripening of those fruits. So we say ethene is used in ripening of fruits. Ethene is used in ripening of fruits. Third one, they are also being used in manufacture of detergents. Detergents are soaps. Those ones we use in cleaning, sabuni. So some of the detergents, we know that detergents are of two. We have what we call soapy detergents and the soapless detergents, but that one will be covered later in organic chemistry too. So these are some of the uses. And the last one, we also have alkenes being used in manufacture of solvents like alkanols. The fourth one, used in manufacture of alkanols. Just as we have seen here, this is an ethene. Ethene has been used. We carry out hydrolysis, then we manufacture ethanol. We can also use them by reacting with steam to prepare alcohol. So under the large scale manufacture of alcohols. So this one here are some of the uses of alkenes. This gives us some of the uses of alkenes. Now our last lesson under organic chemistry 1 is going to be on alkynes. That is going to give us the last part of organic chemistry 1. So we are remaining with one more lesson to end organic chemistry 1. Thank you. Assalamu alaikum.